Good morning students. Electrochemistry. Now what is electrochemistry? It's the branch of chemistry which establish a relation between chemical energy and electrical energy. Okay, relation between chemical energy and electrical energy. Okay. Now, it is a study, it deals with the study of chemical changes which occur on passing electric current into certain chemical systems and also with the generation of electrical current by carrying out certain chemical reaction. Okay. So, now what is electrochemical change? Chemical changes involve the flow of current. Flow of current. That is, certain chemical reactions are taking place by the flow of current. These are called as electrochemical changes. Electrochemical changes. Okay. So, sodium, magnesium, fluorine, sodium hydroxide, etc., which can be obtained in these methods where electrical energy causes chemical reactions. Okay, so electrical energy is converted into chemical energy. So, different substances like sodium, magnesium, fluorine, sodium hydroxide, etc., can be produced. Okay, also certain cells and batteries. Cells and batteries are the substances used to produce electrical energy from chemical energy. Now, next let us discuss on electrical conductance. Electrical conductance. So, what are conductors? Conductors. Conductors are substances which may allow the passage of electricity. Substances which may allow the passage of electricity. Okay. There are two types of conductors. Metallic conductors. Metallic conductors. Second one, electrolytic conductors or electrolytes. Electrolytic conductors or electrolytes. Okay. Now, what are metallic conductors? First one, metallic conductors. What are metallic conductors? Metallic conductors. Conductance in metals is due to the mobility of electrons. Such conductors are called as metallic conductors. So, example metals. Conductance in metals. Conductance in metals due to the mobility of electrons. Okay. Such conductors are called as metallic conductors. So, in this case of metals, conducts electricity, they conduct electricity both in solid state, then molten state or in dissolved state. Okay. Now, as temperature increases, what happens to these metallic conductors? The magnitude of metallic conductance decreases. Okay. Metallic conductance decreases as temperature increases. Why? That we can discuss. Okay. Why? Because at higher temperature what happens? Vibration among the kernels in the metals is taking place. Okay. Kernels gets vibrated. This resists the free flow of electrons. Okay. As the temperature increases, what happens? Vibration of kernels of metals taking place. So what happens? They resist the free flow of electrons. So what happens? As temperature increases, metallic conductance decreases. Now let us discuss next type, electrolytic conductors or electrolytes. Okay. So second type, electrolytes or electrolytic conductors. Okay. Electrolytes. In this what happens? Conductance is due to the movement of ions towards oppositely charged electrodes, which causes transfer of matter and hence decomposition. Okay. Conductance due to the movement of ions. To the oppositely charged electrodes. Oppositely charged electrodes. Oppositely charged electrodes. Okay. And causes transfer of matter. Transfer of matter and hence decomposition. Okay. For example, in the case of sodium, magnesium, etc., they are positively charged ions. They get deposited in the oppositely charged electrode. Okay. So we can obtain these elements during this process. Next, electrolytes completely ionized. Certain electrolytes are completely ionized and certain electrolytes do not completely electrolyzed. Okay. Electrolytes completely ionized are called electrolytes. Completely ionized are called strong electrolytes. Completely ionized. They are called as strong electrolytes. Examples are sodium chloride, KCl, HCl, NaOH, etc. NaCl, KCl, then NaOH, etc. are examples. Electrolytes which do not completely ionized are called in the solution are called as weak electrolytes. Electrolytes do not completely ionized in their solutions. They are called as weak electrolytes. What are the examples? Examples are acetic acid, CH3COOH, NH4OH, ZnCl2, CH3COOH, ammonium hydroxide, NH4OH, then zinc chloride, etc. are examples of weak electrolytes. Okay. Now, next topic is factors which affecting the electrolytic conductivity in electrolytic solutions. Okay. There are certain factors which affects the conductivity in electrolytic solutions. Let us discuss that. Next, factors affecting electrical conductivity. First point, interionic force of attraction. That is, larger the solute interaction, that is, the attraction between the ions, solute interaction increases, what happens? The extent of dissociation decreases, so lower will be the conductivity. This is the first point. Okay. Next, second point is solvation of ions. So stronger will be the solute solvent interaction. Okay. Solute solvent interaction increases. What happens then? So higher will be the solvation of ions. So conductivity decreases as the solvation of ions increases. Okay. Next point, viscosity of solvent. In this case, as the viscosity of solvent increases means larger will be the solvent-solvent interaction. Okay, so the conductivity, solvent-solvent interaction increases means the conductivity decreases. Next, concentration. Concentration also determined the electrical conductivity. That we will discuss, detailed discussion later. Okay, next is temperature. What happens to the temperature? As the temperature increases, what happens? The ions can move very faster. Okay, so as the temperature increases, rise in temperature, conductance increases. Okay, but in the case of metallic conductors, we already discussed, as the temperature increases, what happens? The conductivity decreases. So reverse will be in this case. In the case of electrolytes, as the temperature increases, what happens? Conductivity also increases. This much about, these are the important points in electrochemistry. Okay.